Okay, so before we start, we want to get an idea of what algebra is. Everyone says the word algebra, but I don't know that people really understand what it's doing. So, for example, let's say we had to make an apple pie. Let's call it the apple pie pie. See the pie? Pie pie. Okay, and let's say that the recipe calls for 12 apples to make the pie, and I have 8. And I want to know, how many apples do I need to get to make my pie pie? We all know the answer. We can do it in our head. And this is just a simple example to show you that you do algebra all day long. You figure out how much change you're going to get from the drive-thru when you go to McDonald's. We do algebra all the time. And this one is a very simple example, but hold on, Otto's at the door. Okay, sorry. So, this is a simple example of how we can use algebra to solve things. And we then can use algebra to help us solve much more difficult situations than this. But anytime you're solving for how much of something you need, that is algebra. That is solving for an unknown. So, with this simple problem, which we all did in our head, we could do it with algebra. We could set up a little equation to help us. So I'm going to say, I'm going to let A, some letter, represent the number of apples that I need to get. And then I can use the information that I already know to help me figure out A. So I have 8 apples. Sorry, I didn't like that 8. I have 8 apples. I need A more apples to get 12 apples. A simple algebraic equation. And to figure out our A, we behave like teenagers and we do the opposite of what we see in front of us. And this could be written as A plus 8 equals 12. Otto has a toy. And so to get A by itself, we behave like a teenager and we do the opposite of what we see. I see plus, so I will subtract the 8 from each side. 8 minus 8 is 0, and I figure out that A, the number of apples I need to get, is 12 minus 8, which is 4. Simple algebra. And there's much more difficult problems that we can solve with algebra, so that's why it's important that we learn these rules to help us be able to solve for things that we're interested in as we go forward in life. Okay? All right, so now pick up your pencil. And let's move on. So today we're going to start with 1- and 2-step equations. And we're going to do a few examples. We'll start with 1-step equations. And we're mixing section 2.1 and 2.2 because you've seen these equations before, so this should be a review. And what I'd like you to write down from this slide is when we do start to solve equations, we generally, here's the way we approach it. We start furthest from the variable on the same side of the equals, and then we perform opposite operations. If we see adding, then we subtract. If we see multiplying, then we divide. These are the opposite operations, add and subtract, multiply and divide. There's a lot more operations that we'll do opposite operations for later on, but we're just going to start with adding, subtracting, multiplying, and dividing. So this would go into your notes, what we have over here. Start furthest from the variable on the same side of the equals, and then perform the opposite operations. All right. So we're going to do quite a few on this page. We're going to start with number 1. So please write down m plus 12 equals 10. If I can get my pen to work. And this is just like the apple problem. Okay? If I want to get m, if we are asked to solve an equation, what that means is we want to get the variable by itself equals to something. And the variable by itself is when the variable has a multiplier in front that is just 1. So 1x can be written as 1x, or it can just be written as x. Generally, we just write it without the 1. Okay, so that means I want to get this m by itself. So we now start on the same side of the equals as the variable, furthest away, and we do opposite operations. So this says plus 12, so we would do the opposite, and we would subtract 12. We have to do it on both sides of the equation to keep the equation balanced. What we do to one side, we have to do to the other. 12 minus 12, well, that goes to 0. That's why we do that. And on the left, we are left with m equals 10 minus 12 is negative 2. And there's our answer. And what we just did is called a one-step equation. Come here, Otto. Come on. Come on. So we get m equals negative 2. And we're done. We got the variable alone with a coefficient. The number in front of the variable is 1. That's when you know you're done. Come on. There he is. This is the one you've already seen. There's Otto. Now, go do what you're going to do. All right. So let's write this second one. Negative 2 equals g minus 9. Everyone should be writing these problems into your notebook. We do examples for a reason. It's fine that the g is on the right side of the equation. So to solve this, we start on the same side of the equals, furthest away from the variable. Sometimes it's nice to put a box around the variable so we see what we're trying to get by itself. And then we do our opposite operations. It says minus 9, so I will add 9. And I have to do it to both sides of the equation. Negative 9 plus 9 is 0. So that goes away. Negative 2 plus 9 is 7 equals g. And we are done. There's our solution. So the first one we had to subtract as the opposite operation. The second one we had to add. This next one, number 3, copy this down please. Negative 7y equals negative 91. When I have a negative 7 in front of the y, what operation is going on in the equation right now?
Multiplication.
Thank you. It is multiplication. So the opposite operation would be division. We show our division like a fraction. So we draw a line underneath, and we divide by the number in front of the variable, negative 7. Negative 7 over negative 7 is 1. So that's how we get 1y. And negative 91 divided by negative 7, we're looking at 13. Here's our box. This is the way I want to see your work on your homework. So there, we've had one where we subtracted to the other side, we added, here we have divided. Now we have the next one, a over 9 equals negative 4. When we have a over 9, that means division. So our opposite operation is going to be multiplication. So we will multiply each side by the denominator. I call that clearing the fraction. And when we multiply by 9, we end up with 9 over 9, which is 1. So they cancel. And the coefficient in front of a is 1. So we get a equals negative 36. Negative 4 times 9 is negative 36. And we have solved our equation. Okay? So that's 4 examples of one-step equations. Any questions so far? Okay. All right. The next ones are when we have a fraction in front of the variable. And let me move down here and make a little space. Let's get rid of my notes here for now. Come on. And So when I have a fraction in front of the variable, we're going to do number 5. With the fractions, I make it a two-step equation. I multiply by the bottom first. The bottom is called the denominator. And then the second thing I do is divide, divide by the top, the numerator. That stops people from making some errors that I see quite often. The top is called the numerator. So if we look at number 5, we have 2 over 3x equals 10. So I make this into a two-step equation. Multiply by the denominator first, and then divide by the numerator. So I'm going to multiply by 3. Again, clearing the fraction is what I'm doing there. Nobody likes working with fractions. So by multiplying by the denominator, we get 3 over 3, and that clears the fraction, leaving you with 2x equals 10 times 3 is 30. Now we're looking at the same type of equation we just did. Now we divide by the numerator, which is 2. And we're looking, 2 over 2 is 1. So we get x equals 30 over 2 is 15. Box your answer. Okay? So when there's a fraction in front, make it a two-step equation, multiply by the denominator, and then divide by the numerator. Now I want to look at number 7. This one looks a little different. It's got a negative in front. And people always have trouble deciding when to deal with the negative. So what I suggest you do is you rewrite this problem. Sorry, funny pen. Being weird. There we go. Rewrite the problem, attaching the negative to the top or the bottom, but not both. All right, so when you've got a negative out in front, rewrite that problem with that negative either attached to the top or the bottom. So what I would do here is I would say, I'm going to attach it to the top. Negative 6 over 5k equals 12. So that way it's easy to see I don't deal with the negative until I deal with the 6. So now we'll multiply by the bottom to clear the fraction. We get a cancel there. We're looking at negative 6k equals 60. And now we will do our second step, divide by negative 6. They cancel, divide by negative 6, and we get k equals negative 10. That's your answer. Okay? So when that negative is out in front, rewrite it, attaching it to the top or the bottom, but not to both. All right. So we've done one step, and we've done when we have a fraction in front. Any questions on what we have so far? Okay. All right, let's move on. Okay. So now we're going to move on to these two steps. The suggestion here, to solve a two-step equation, undo the addition-subtraction to remove the constant term, and then undo the multiplication-division. Same idea. Start on the same side of the equals as the variable, furthest away, and then do opposite operations. So let's look at number 10. Please write this down. We have 2n minus 5 equals 11. Hey, Hobby, can you read it? All right, we're going to start on the same side of the equal sign as the variable, furthest away. So I see minus 5, so my opposite operation is going to be plus 5. I have to do it to both sides. Negative 5 plus 5 goes to 0. So on the left we have 2n equals 11 plus 5 is 16. Okay. And then we will do the opposite operation. 2 next to an n means multiply, so we need to divide by 2. And we get n equals 8. Solution. Box your answer. Okay? The next one I want to look at is number 12. And this one's important because it's written a little differently. 7 minus 3y equals 34. Sometimes when it's written this way, it's hard for people to see what the opposite operation would be. Can somebody tell me what you would do first? Zoe? What would you do first?
Would you subtract 7?
You would. And the reason people have trouble seeing this is that there's no plus or minus in front of the 7, but what we have to realize is that this could be rewritten. We can rewrite this as negative 3y plus 7 equals 34. And then it makes it easier to see I need to subtract that 7. So you're right, Zoe, we would subtract 7. 7 minus 7, that goes to 0. So we're looking at negative 3y is equal to 27. And now we can see we just divide by the negative 3. And we get y equals negative 9. Answer, box your answer. Okay? So when they're written with the constant out by itself, you may want to rearrange it so you can see that what the opposite operation is. You don't have to. If you see it and you can tell you can do minus 7, that's fine. But it may be helpful to do the rewrite. All right, let's try a few more. Okay, so we will have fractions sometimes. So we're going to do number 14. Otto has a toy, sorry. Hey. Could you take it somewhere? Go on. We have 11 equals c over negative 5 plus 8. Sorry, I'm going to get Otto out the door. Okay, so on this one, let me see. Patrick, can you help me with what we would do first?
I don't know.
Okay, so this c is what we want to get by itself, okay? So you want to start on the same side of the equal sign, furthest away from the c, so that puts us at this plus 8. What's the opposite operation for that, Patrick?
Subtraction.
Yeah, minus 8. Good. So we're going to do minus 8 on each side. 8 minus 8, that goes to 0. That's what we want to see happen. 11 minus 8 is 3 equals c over negative 5. All right, I'm staying with you, Patrick. You're finishing this guy. All right, we have c divided by negative 5. What's the opposite operation?
Multiply.
Thank you. We're going to multiply by negative 5 on each side. That clears the fraction. Sorry. And so negative 5 over negative 5, that goes to 1, which is what we want to see. So the number in front of c is 1. And it's okay if it's on the right side. And so we get c equals negative 15. Box that answer, and you are done. All right, next one I want to look at, oh good Lord, this dog, 17. We're going to have negative 10, write this one down please, plus 7/4 p equals negative 38. And Jet, would you help me please with this one? What would you do first?
Plus 10.
Very nice. We do it on both sides. Negative 10 plus 10 goes to 0. So on the left we've got 7/4 p equals negative 28. All right, Jet, do the two-step on the fraction, please. What do we do next? Clear that fraction.
Would you do multiply times either 4 or 7?
So it wouldn't be the 7. You multiply by that denominator. So multiply by 4. Your first instinct was correct. And that gives us 4 over 4, so those 4's cancel. We have a 7p left, and 28 times 4 is, so negative 28 times 4 is negative 112. All right, Jet, finish it up. This means,
Can I?
oh, sorry, go ahead.
Oh, sorry. Just divide by 7.
Very nice. 7 over 7 is 1. That's what we want to happen. We want the coefficient, or the number in front of the variable, to be 1. And 112 divided by 7, negative 112 divided by 7 is negative 16. Box your answer. Okay? All right, any questions on those? Okay, last one that we have to do is when it's written a little bit differently. And it's when it's a big fraction equals a number. And so we can't do the adding and subtracting first if the whole top is divided by something. So when it is a big fraction like this, I say clear that fraction first. And we clear fractions by multiplying by the denominator. So let's look at number 20. We have n minus 5 over negative 2 equals negative 7. And when it's a big fraction like this, clear the fraction. So Remy, what would I multiply by to clear the fraction?
Multiply by 8.
By what? Oh, sorry, we're doing number 20.
Oh shoot. Multiply by 2.
I was like, where are we getting 8? Multiply by negative 2 on each side. All right, so this negative 2 over negative 2, they cancel, and what that means is it becomes 1. Negative 2 over negative 2 is 1. And now we've got n minus 5 equals negative times a negative makes a positive 14. Now we have one step left. Layla?
Me or the other Layla?
Oh my gosh, I have two Laylas. I do. I met Layla. I don't know last names, but I do know first names. Layla, who is wearing glasses today. What do I do, Layla, with glasses?
You have to do like what you do on the right side to the left side. So minus or add 5 and then
Thank you.
add 5 to the 14.
Perfect. Negative 5 plus 5 is 0. That's how we've moved it to the other side. N equals 14 plus 5, which is 19. Box your answer, and you are done. Okay? All right. Those are all of our examples for today. So your homework, let me take you over there. I'm going to stop my video.